Hello everyone, this question is from Irodov Fundamental Equation of Dynamics question number 63. The following parameters of the arrangement of figure 1.11 are available. The angle alpha, which the inclined plane forms with the horizontal, and the coefficient of friction K between the body M1 and the inclined plane surface. The masses of the pulley and the threads as well as the friction in the pulley are negligible, assuming both bodies to be motionless at the initial moment. Find the mass ratio m2 by m1 at which the body m2 starts coming down, B starts going up, C is at rest. The figure is given. This is the figure. M2 is here hanging over the pulley and M1 is on the inclined plane. Both of the masses are connected with the threads, massless thread and massless and frictionless pulley. So let us solve this question. We will go case by case. Case 1, case 2, case 3. So this is the diagram which I made. When M2 has the tendency to go down. So when M2 will go down means M1 will come up on the inclined plane. So friction will be acting opposite to the motion of it, the tendency of motion of it. So friction will be downward along the inclined plane. Component of gravitational force along the inclined plane is m1g sine alpha acting downward, and component of gravitational force acting on m1 perpendicular to the plane is m1g cos alpha. N is the normal reaction. Okay. And this m2g is the gravitational pull on the mass m2. Since the thread is massless and pulley is massless and frictionless, it means the tension in the thread will remain the same throughout, and there will not be any frictional force acting on the thread by the pulley because pulley is frictionless. So let us write the equation for case 1 when M2 has a tendency to come down. First of all, there is no motion along the perpendicular of the inclined plane. It means n minus m1g cos alpha will be equal to m1 into 0. There is no acceleration in perpendicular direction to the plane. So n will be equal to m1 into g cos alpha. Now we know that friction force F is equal to K into N, so K into M1G cos alpha. From Newton's law of motion, for the system of masses M1, M2, thread and pulley, the forces responsible for the motion, the condition should be M2G is pulling the mass M2 down, and M1G sine alpha is acting in, which is resisting the block M1 to go up, as well as friction force F is resisting the block M1 to go up. So total force responsible for the motion of this system will be M2G minus M1G sine alpha minus F, and since it has a tendency to go down, so it should be greater than 0. Therefore, m2 by m1 upon solving will be greater than sine alpha plus k into cos alpha. So this will be your first answer. Part A answer is here. Next, we will consider when m1 has a tendency to come down along the inclined plane. So we will make another diagram and show the forces like this. Since m1 is now has a tendency to come down along the inclined plane, friction force will be acting in this direction. So we again will write the Newton's law of motion for the system of this. So m1g sine alpha is setting the motion in this direction. F is opposing it, so minus F, and m2g also is opposing the motion because it will try to pull down the thread. So this is opposing it, so minus m2g. So this should be greater than 0 for the motion to occur in this direction. So therefore m2 by m1 will be sine alpha minus k into cos alpha. So this will be a second answer. Now between these two conditions, m2 by m1 less than sine alpha minus k cos alpha, and the first conditions which we have got in the last page, m2 by m1 greater than sine alpha plus k cos alpha, the system will be at rest. So that is your number 3 answer. So hopefully you understood the concept behind it. In case any problem, please do write in the comment box. I'll come back. Thank you.